As we grow, the hurdles will be more. Each time we are washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. See the sunrise tomorrow, inspire the world to follow.
Okay, so today we are going to start the topic on single phase induction motor in the machine curriculum of machine 2. So in our class 1 or lecture 1, we are going to discuss the following topics under the introduction part. The first one is that why should we will study single phase induction motor. Second is what are the different application area of single phase induction motor. And thirdly, we will study a comparison study of single phase induction motor with 3-phase induction motor. And then we will discuss the construction of single phase induction motor. What are the different parts? What are the building blocks that form that single phase induction motor? And consequently, we will build our knowledge that why single phase induction motor is not self-starting motor, and what are the procedures or the methods can be developed so that it will become a self-starting motor. And then we will build our basic concept on field excitation and generated voltage, and there we will discuss this MMF equation for single phase equation, which will help in build our knowledge to the production of rotating magnetic field for a balanced 2-phase supply, and then rotating magnetic field, and then rotating magnetic field in a single phase induction motor, right? Rotating magnetic field in a single phase induction motor. And in the construction part, we will discuss with pictorial representation, with picture this different parts of this single phase induction motor. And we will also discuss the nameplate specifications, nameplate details of a single phase induction motor. And this is all about our agenda of lecture number 1. So let's proceed further. So before we proceed further, let's check our preliminary knowledge through some quiz session. Now the first question is, single phase induction motor is self-starting motor. So there are two options, true or false. So students, you should first give your answer and then check the right answer, and so on for this quiz session. Okay, so the right answer is yes, it is true. Single phase, no, the answer is here wrong. So the answer would be false. Single phase induction motor is not self-starting motor. So the answer is false. And the second question is single phase induction motor can have wound type rotor, that is slip ring rotor, which we have seen in case of 3-phase induction motor. So again you have to select between true and false. So the right answer is false, because single phase induction motor is has only squirrel cage type of rotor. Third statement is single phase induction motor produce pulsating, or rather we can say alternating field. Again the option is between true and false, and the answer is yes, true, because it has single winding. Up to 2 winding rotating magnetic field is produced, but for a single winding the magnetic field is pulsating, and that is the reason why single phase induction motor is not self-starting motor, right? So if we proceed further, so why should we will study single phase induction motor, right? So the single phase induction motor displays less satisfactory operating characteristics in comparison with 3-phase induction motor, but still it achieved nevertheless a wide field of applications where there is polyphase supply is unavailable, that is in some industrial applications and in our domestic purpose, because there the supply is single phase, right? So the first reason is unavailability of polyphase supply, and I have explained this point. Okay, now what should be the second point? Second point is low power application for constant speed drive. Now single phase induction motor has only squirrel cage rotor structure, so it is very rugged, it is cost effective. So as there is no slip ring or brushes, so it has less maintenance requirement, so it is much more reliable. So these are the few reasons behind the popularity of single phase induction motor in low power application where accurate speed control is not a prime requirement. Okay, so the second reason is low power application for constant speed drive, and I have explained it that where there is no accurate speed control is required in low power application, there single phase induction motor is preferable in comparison with three phase induction motor due to the cost factor, right? Now what are the different application area of single phase induction motor? Just few minutes back I have mentioned that its main application area is low power applications, low power application for constant speed drive. Now advancement in design have made the single phase induction motor quite satisfactory in its smaller range, that is the range is basically a few kilowatt range, so that millions of them are in use in commercial and domestic field with reduced components and lesser cost for driving load like compressor, blower, belts, fans, refrigerator, air condition, to mention a few. Okay, so these are the applications of single phase induction motor: refrigerator, air condition, fans, dryers. So these are the application area of single phase induction motor. Now what are the drawbacks of single phase induction motor? So we have just mentioned first drawback is it is not self starting, right? and second is it has a reduced power factor and efficiency. Okay, so reduced power factor and efficiency. So it has a reduced power factor and efficiency. So this is absence of starting torque, right? And the second reason is a reduced power factor and efficiency. Okay, so now we are, let me so comparison with three-phase induction motor. Now we will do a little bit of comparison study with respect to three-phase induction motors. So let me switch into pen option, or let me switch into laser pointer. So construction wise there is no such difference with respect to three-phase induction motor, except some difference in stator part, right? So as we have seen in case of three-phase induction motor, the stator are laminated to reduce the eddy current loss, and the slots are made of silicon steel to reduce the hysteresis loss. So this is the same case in case here, right? So the stator of three-phase induction motor is laminated, as I have mentioned, and this slots and tooth stacked together, which is forming basically the stator core, are made of silicon steel. Okay, so although the three-phase induction, like this, like in the stator of a three-phase induction motor, there are laminated silicon steel sheets with slots and tooth linkage together to form stator core, and same are there in single-phase induction motor also. But the major difference is that the single-phase induction motor size is 100 times lesser with respect to three-phase induction motor. And one more thing, single-phase induction motor has single stator winding, whereas in case of three-phase induction motor there are three winding which are 120 degrees space apart, and the rotor are same like a three-phase induction motor squirrel cage rotor. It is also same in case of single-phase induction motor, right? So now when a polyphase supply given in this three-phase induction motor whose winding is 120 degree apart, it will producing a rotating magnetic field, right? Now if accidentally one phase is damaged, then and this condition is happen when this motor is carrying a load half than that of the rated load. So the motor will start continue rotating with the lesser speed, because with the damage of this single phase of a three-phase winding, the remaining two phase will work similar to a single phase induction motor. So what we have seen, that three-phase induction motor is self-starting motor, but when we come to that discussion of single phase induction motor, due to the presence of a single phase winding, it's failed to produce a rotating magnetic field. Rather, it will produce a alternating magnetic field like a sinusoidal, like a sinusoidal wave. Okay, like a sinusoidal wave. So it will produce a magnetic field like a sine wave. So previously from 0 it will go to the maximum in one side, then become 0, and again it will go maximum in reverse direction. So the rotor start rotating in a one direction, and then again the torque is try to rotate it in a opposite direction, but due to inertia it is not possible, right? So that's why rotor start vibrating instead of rotating in a single direction. Okay, so now we will discuss a little bit of construction, and consequently we will discuss why this is not self-starting, right? So before we proceed further, we will show you some figure. So first we will show you that figure of a three-phase induction motor. So this is the image of a three-phase induction motor, right? So housing, stator, electrical connection, rotor, end bells, sorry, so this is right. Let me again select that pen tool. So sorry, laser pointer. So this is a pictorial representation of a three-phase induction motor. So end bell, this is the shaft, this is the mounting base, this is the stator, this is the rotor, and similar thing is we will see in case of single phase induction motor, right? So this is a construction of single phase induction motor with different parts, right? So this is the single phase induction motor. This is a capacitor start is connected with auxiliary winding to make this single phase induction motor self starting, and this is the nameplate where all the details of a single phase induction motor use. And this is a centrifugal switch is used to cut that auxiliary winding once the motor start rotating, rather it achieve that initial inertia for starting. Okay, so let me show another picture for much more. So this is the picture of a single phase induction motor, and this is the circuit representation of single phase induction motor. This is the circuit representation of single phase induction motor. Okay, so this is the another picture with cutaway view. All the parts are detached from the motor. So this enough to build a concept about this constructional feature of three-phase induction motor. Okay, so I have mentioned that stator is the stationary part, and it has single winding, and AC supply is provided in single phase induction motor. And also I have mentioned that the fact of eddy current, it is laminated, and silicon steel is used to reduce the hysteresis lot in slots and stamping, right? Except that the construction of stator is similar to three-phase induction motor, except that there is a single winding I have mentioned. And one more thing, that single phase induction motor mostly use concentric coils, which is easily can adjust the number of coils with the help of concentric coils. The MF distribution is almost sinusoidal. I have shown it previously. So except, I have mentioned earlier, the except threaded pole type induction motor, single phase induction motor, it has two winding, one is main winding, and to start the single phase motor, or rather to give the single phase motor the initial inertia, it has a auxiliary winding, and which is remain with respect to the main winding in space quadrature, that is in 90-degree position. Okay, now we will see the rotor. I have mentioned that it is similar to that three-phase induction motor cuirassier structure. There is no basic difference. It is similar to that. Okay, and one more thing, if we see later on through animation that the rotor bars are little bit skewing, not exact parallel to each other, to run the motor smooth and noise free. Okay, so we have mentioned this is that it is similar to this three squirrel cage rotor of a single phase induction motor, three phase induction motor. So there is no provision, as we have seen, because it is shorted, the buds are shorted with end rings, so there is no provision to change the resistance, which we have seen in case of slip ring induction motor, in case of three phase induction motor. So although these are absence in case of single phase induction motor, there is no slip rings brushes, so it is more robust and simple structure, right? And these end rings are majorly made of aluminum or brush copper. So this is a picture. So single phase supply is given. This is the stator winding. So a electromagnet will produce, which will produce a alternative north pole, south pole, and this is the rotor. So accordingly, a pole will produce in the rotor of the single phase induction motor, and due to some internal physics, it will start rotating. And one more thing we should remember, in case of this stator, in case of this main winding, this main winding is distributed along the stator periphery, only the 2/3 portion of the stator periphery, not the whole part. So as it is only cover up the 2/3 portion of the stator periphery, so for a same size of a three-phase induction motor, the output power is lesser in case of a single phase induction motor, right? So now we will discuss a little bit on this working principle, or why it is not self-starting, although we have discussed so many topics regarding why it is not self-starting motor. Now this is a typical nameplate specification of a single phase induction motor. This is a 1 horsepower motor, 230 volt, 50 hertz supply. The rotation speed is 1400 1400 rpm. It's insulation class of 5. So these are the specifications, nameplate specification of a single phase induction motor. Okay, now working principle of a single phase induction motor. Now so which I have mentioned that single phase induction motor has a distributed stator winding and a squirrel cage rotor. So when a single phase supply is given to the stator of a single phase induction motor, and pulsating and alternating pulsating, that is the alternating magnetic field, is produced in sinusoidal nature. So it will increase in one direction, then it becomes 0, and then it will decrease in opposite direction. And this alternating field is induced an EMF in the rotor conductor by transformer action, since rotor has a closed circuit with the end rings. And we will see that the force produced inside this rotor, we can see here. So these are the cross cross current is flowing due to this electromagnetic induction occurring inside the rotor. Transformer action is happening. So the upper part of the conductor of a rotor is carrying cross current and the lower part is carrying the dot current. It is the rotor magnetic field is aligned with this stator magnetic field. The alignment is same, right? And there is no angle between these two, stator field and rotor field. So the torque angle is 0. So the torque is 0, and on top of that, the upper part, or we can explain in this way, the upper part is carrying cross current. So if we use our thumb rule, so we will see that for cross current, right? So for cross current, so cross current, so that means the arrow is going inside. So that means if we applied the corkscrew rule, so this cross current, so this is cross current, and this is my, suppose, dot current. Suppose this is my dot current. So the direction is opposite. So the direction is opposite. So here we can see the force is downward for cross current and the force is upward for dot current. So these two forces cancelling each other. So there is no production of torque. So the torque angle is 0. So there is no production of torque. So the single phase induction motor is not a self-starting motor. But if somehow I give initial rotation or initial inertia to the rotor in a single direction, then this rotor start rotating in a single direction. And to provide this initial rotation, we will study later that so many techniques has been developed, and for that purpose we used auxiliary winding which is in 90 degree, a space quadrature with respect to the main winding, in addition to a capacitor. Okay, so now through animation we will discuss this. So let me show, this is the main winding and this is the starting winding, that is the auxiliary winding. So it is in 90 degree position, that is space quadrature. Once the motor start and attain a certain speed, the starting winding is cut off from the machine through a centrifugal force, right? Through a centrifugal force. Now through animation we will, so this is our single phase induction motor, right? So this is our single phase induction motor. Okay, so this is our single phase induction motor. So this is the capacitor which is connected with the auxiliary winding to start the induction motor initially. So as I have mentioned earlier, so through this animation I will show, this is the rotating part, rotor, this is the rotor part in skewing condition. So see here the rotor bars is skewing to noise free operation, and this is the stator, this is the main winding, and this is the auxiliary winding which is in 90 degree with each other. And I have mentioned this capacitor is connected with this auxiliary winding to provide the inherent starting torque for a single phase induction motor. Now assume there is only one coil in auxiliary and main winding. Suppose there is only one coil for ease of our understanding. Now suppose the current is flowing through this, no current is flowing through auxiliary winding, so only the current is flowing through this main winding, and this produces fluctuating magnetic field, and this rotor is rotating inside this fluctuating magnetic field. Now interesting is that the rotor is rotating in the same direction. The reason is fluctuating field is a combination of basically two rotating magnetic field, which is double field revolving theory, which we will discuss later. Two equal and opposite field, double, one is backward field and one is forward field. Now rotating magnetic field is inside the rotor. Magnetic field is varying, so due to transformer action a current will produce, and this is sorted with end rings. So according to the Lenz's law, when a current carrying conductor placed in a magnetic field, it will experience a force, and due to this force the rotor start rotating. Now the interesting fact is that two equal and opposite force is producing. We have seen two equal and opposite forces producing, equal and opposite. So this is F1, this is equal and opposite. So both are cancelling each other. So it is due to inertia the rotor failed to start because the torque is 0. So rotor is vibrate. But if some initial rotation is provided, as I mentioned, between this F1 and F2, F1 is greater than F2 or F2 greater than F1. So it will start rotating with the rotation in which direction the initial rotation is given. So now how to provide such initial rotation? Now for that the scientist Nikola Tesla has given a ingenious solution. So if we between these two F1 and F2, if we can cancel one field, then there exists a single field, so there is no issues, right? So easily, so okay. So just to quick recall, so that you can understand what is happening. So this rotor bar skewing, stator winding, main winding, and there is auxiliary winding. Quick recapitulation, 90 degree with each other. That capacitor is connected with this auxiliary winding to provide that initial starting torque. And for ease of operation, I have mentioned that we have just assumed single coil for main winding and auxiliary winding, and preliminary we have assumed that no current is flowing through the auxiliary winding, only the main winding is flowing, carrying the current. So here that double field revolving theory come into the picture. Backward field and forward field, to equal and opposite field will produce, inside which this rotor start rotating in a particular direction. And next we are going to discuss that the field is producing inside this rotor due to that transformer action, that is the electromagnetic induction. Okay, so this is double field revolving theory. This is double field revolving theory. And now this transformer action is happening, and this rotor, inside the rotor there is a field is producing and the current is producing due to the transformer action, and Lorentz force come into the picture, and two opposite and equal forces producing. Okay, so some problem with this my PowerPoint presentation. Okay, so So all these things we have covered till now. So let me wait for some time. Okay, now this rotor field come into the picture. Okay, so here we have mentioned that two equal and opposite forces is producing inside this rotor. Okay, and so this we have mentioned. Now equal and opposite force is producing. Now if I give some initial rotation, so in between these two forces, one will become predominant than the other, and it will overcome the inertia issues and it will start rotating in the direction where this initial rotation I have provided. Now Nikola Tesla, he has given this ingenious solution that if we can cancel any of the rotating field, we will be able to start motor. This can be done using auxiliary winding and that capacitor. Now this auxiliary winding produce similar to main winding to opposite revolving magnetic field. Now between these two revolving magnetic field which is producing in the auxiliary winding, one field is cancel the magnetic field of the main winding, and the another field of the auxiliary winding is added with the main field winding, which results in a single magnetic field which rotate in a specific direction. Now once the rotor start rotating and achieve the certain speed, through a centrifugal switch we can cut this starting winding and that auxiliary winding. Okay, so this is all about our lecture number 1, and we will discuss later on the double field revolving theory in case of single phase induction motor in my later lecture.